All right, it looks like we're live, so we're just going to give it a couple minutes before we get started here.
We're live. The first live.
First of many good ones.
I don't know what the world will do with Dave live.
Looks like we do have a couple people tuning in already. We are going to just give it a couple more minutes to give more people time to log on for our 11 a.m. start time. Dave has some really great topics for us today about remote sensing.
All surveyors are geeks for technology. That's just the way it is today.
You think that's going to be the majority of our viewers today?
I don't know who's showing up. I wonder if my buddy Joe Henderson, the traffic engineer, is going to show up today.
Well, we'll see. They'll have to send us a little message in the chat box to let us know who's on.
I wonder if I can. What will happen if I go to Facebook? Where does it show up on Facebook here?
It shows up on our Coffey Engineering page. And there will be a little bit of a delay. You have to scroll down a little bit into the posts, and you'll see us there.
I don't see us.
I do on my, I'm logged on onto my cell phone.
Well, maybe that's what I have to do since I'm on my computer.
And I did just pin it to the top as well. And I'm going to close out of it because everyone's going to hear us multiple times if I have it also open on my phone. Looks like we have about 7 people on so far. That's great. Bo Williams says, "What's up?"
What is up?
Hello, Bo. Thanks for joining us today. Looks like we just spiked at 10 people. That's great. We're just hitting our 11 a.m. start time. So I'm going to go ahead and introduce myself and introduce Dave. Looks like we have some more people typing in. Chase Corbridge, good morning all. Hi, Chase. We're happy to be here with you all today. So without further ado, Tina, hello, Tina. So hello, everyone. I'm Marissa Maruli. I'm part of the communications team here at Coffey. We're so excited to be streaming live with you today. We have a great lineup of information from none other but our CEO, professional engineer Dave Coffey.
Hey, I'm a professional surveyor too.
Professional surveyor.
You can't leave that out.
After teaching us about the fascinating world of remote sensing, Dave will open things up to a live Q&A. So in order to ask any questions and have them answered by Dave at the end, please do go ahead and type them in the chat box here. And if you just want to say hello or write any comments along the way, feel free to do that in the chat box. We'll do our best to monitor them and respond. But again, anytime that you want to go ahead and ask a question, just please do that in the chat box and we'll be sure to answer it. Okay, I think we're about ready to dive into today's topic, the exciting technologies involved in remote sensing and how they benefit the engineering and surveying industry. Dave, it's time I pass the mic over to you. Can you give us a brief outline of what you'll be talking about today?
Well, sure. I can talk about how remote sensing has been made an impact in Coffey Engineering. We've been doing it actually for quite a long time without really realizing the industry is calling it remote sensing. We've had this technology at Coffey in some form or another for about 10 years. But it hasn't been until recently that the technology has really taken off with being able to attach the technology for UAVs and drones and boats for crying out loud. I'll talk about our little boat project here in a moment, but LiDAR, the term LiDAR, you'll probably hear that. It's a technology that uses lasers to remotely measure a variety of different things, including distance and colors and infrared. Us at Coffey are only using it for primarily engineering and surveying related technologies. Anything else I need to dive in on that topic, Marissa?
If you can just let us know a little bit about can you help define what remote sensing is for those who might not be as involved in the industry, just so that they can understand like what specifically could be a couple.
Yeah, I'll do my best to kind of indicate what that is. It's basically taking measurements instead of directly with boots on the ground. It's taking measurements remotely, whether that's from a tripod sitting on the ground, looking into the distance, or from a drone in the air, taking pictures, taking readings from the ground. We actually have a guy out in a mine site today, going in an underground gold mine, mapping and mapping remotely some dangerous areas in an underground mine.
And how is he doing that thing? What does he use to map the mine?
He's using a terrestrial-based LiDAR scanner.
Wow. And what does LiDAR stand for?
Gosh, I'm not sure what the actual term is.
But it's like pulsing light, right?
It's pulsing light, yeah. Mm-hmm.
And would that be the same thing as when you're in, perhaps a room with somebody helping you measure the space of a room, and you see them kind of flash a laser beam at the end of the wall, and it tells you the dimensions of the room instead of using the old-fashioned tape measurer?
Exactly right. That's effectively the technology that we're using. You're absolutely right. You must have been talking to Brandon, our LiDAR technician.
Yes, definitely. Brandon's been a super big help this month with our remote sensing campaign. So to summarize it, remote sensing is just gathering characteristics or data of an area without physically touching it yourself, right?
Correct.
Okay.
So I got called. This is the very first time I got involved in a remote sensing project was with a bentonite manufacturing plant, and they wanted us to come into the project and measure up where their beams and columns were with a tape measure and general survey instruments. And we looked at that project, and the whole point of that project was so they could put some new equipment in and have it pre-manufactured to fit perfectly into the existing infrastructure of the building. And I looked at that project, and I said to the project manager from that plant was, this is a great opportunity to actually do a 3D scan of your support system. And he didn't understand what that meant but what we were able to do was show him what the 3D scan did, which was create effectively a 3D model of the existing infrastructure, and then compare that to the measurements that we would have taken without that technology, using just a sketch on a pad, and then trying to transfer that into a CAD program that their designers could then use. And we were able to measure that the insides of that building so well that they were able to manufacture the piece of equipment that they were trying to mount inside that facility so well that all they had to do was bring it in, hoist it up, and bolt it in place. Where had they not opted to do that, they would have had to do a lot of fabricating on site. So we were able to use this technology to help that manufacturing plant, save probably 3 days of downtime. Another example of what we've done in the past was our local cement plant has a big cylindrical kiln where they put all of the ingredients for cement in this kiln, and that kiln rotates, and inside that kiln they blast superheated oxygen and fuel, and it then it not only causes the chemical reaction, but it also burns away some of the lining of the kiln. Well, the plant manager came to us and said, you know, our sensor and our information in that kiln, it's eroding. Since we don't have it centered exactly within this kiln, it's eroding the lining of our kiln, and it costs $5 million every time we have to replace this kiln. So and they have to replace it because of an uneven burn. So we were able to go in there and scan with remote sensing, because we couldn't go in there. We could stand at the end and look in, and then using that scan information, predict or calculate the exact center of that kiln and help align their equipment so that they could, as perfectly as possible, center their mechanisms, their sensors, so that when they re-kiln or reline the inside of that kiln and turn it on, it would burn in a regular pattern rather than in an oblong or uneven pattern. And we ended up saving them millions of dollars. The Mountain Cement was very happy with that. Another example I'd like to share with everybody is you know, what we've done for the University of Wyoming. They asked us to do a detailed survey of the Geology Museum, and we used a terrestrial scanner, and I hope this picture shows up, Marissa. How do I, let's see here, share my screen. We were able to look at this University Geology Museum, and for those of you who know the University of Wyoming, you know about the iconic Tyrannosaurus Rex. Well, we were able to go in and do a highly detailed model of the front of the Geology Museum, as well as the Tyrannosaurus Rex that you can see. Here's another model of the T-Rex. Well, the University of Wyoming thought that was really cool. They weren't quite sure what to do with it, but they asked us to do this same kind of terrestrial-based scanning for the Energy Resources Center that was constructed. So this is a point cloud that was generated from the terrestrial-based LiDAR scanner, where you can see this courtyard was where the new Energy Resource Center was or is today, and they were able to use that point cloud to help connect some existing buildings. You can see exactly where the windows were, and those are the first projects within the last 10 years that we got involved in remote sensing. Pretty proud of that technology, and we've done several little projects like this, but it hasn't really taken off like I'd anticipated it would until we started getting involved with the use of drones. So a couple years ago we purchased a Wingtra drone, and I'd like to show you this video if I can. Marissa, can you see the video?
Yep, we can.
We're about to see our Wingtra take flight, and mounted on this Wingtra drone is a very good camera, and there it goes. This is why I geeked out over the technology, because this thing goes up in the air and takes high density imagery that we can use, similar to what photogrammetry has been used for in the past in fixed wing aircraft. So now we can do we can do the same type of remote sensing to create really good and really precise topographic maps of our projects. You know, we can save a tremendous amount of time by sending that plane up into the air for a lot of projects. There's definitely a size limit that it makes sense to do it with more conventional equipment, so we've also done some large wind farm projects where it didn't make sense to use the drone, and we went ahead and hired and partnered with a company, Ayers and Associates, with their fixed wing aircraft. But this allows us to do so many interesting things. This particular Wingtra project, or Wingtra drone, we used on a reroute for a transmission line project that we're working on, and I'll go ahead and show kind of that video.
Without revealing too much information about this project.
Can you hear it, Marissa?
Yes.
We've got a couple.
This was a project that Brandon did. It's a 10-mile reroute of a transmission line project over some very difficult terrain.
Because everything looks smaller on the screen. So, but here's some contour relief for you.
Wow, look at the detail.
Massive hillside.
Yeah, it picked up all the trees and everything.
And to hike to the top of. And these are trees.
And it's a good thing Brandon's in shape, because I don't think I could probably have done this as well as him.
No. Project here, like I said, was 10 miles and had very extensive relief. These features here.
So was this project with the Wingtra, Dave, or was it with something else?
Well, yeah, we combined the Wingtra ortho photographs with a with a LiDAR flight that we use with our octocopter drone.
I can't imagine the time efficiencies when using the drones as opposed to more conventional equipment and scanning an area like this.
It is definitely a time saver. We could not have done as good a job with this by any stretch conventionally.
One of our colleagues is typing in, Drew Burr. He says drones are the future of surveying, and Chase Corbridge says, as a surveyor, I take some offense to that, Drew.
We have both coverages. You can see here, this is all high resolution data. Some of the poles were captured here.
So not only did we perform remote sensing with our drones on this project, but we also use ground-based remote sensing. So what we see in this picture is one of our surveyors coming back up to a ground-based scanner, and then we added the ground-based scanner into this project so that we could precisely map the location of the existing transmission line. So you can see, so what we were able then to do was incorporate all that data together and provide our client with a highly accurate 3D model of not only the terrain, so they could plan a reroute, but also the precise location of the transmission lines themselves with the sag, so they can make sure when they design a crossing that they have that they can safely and correctly design a new transmission line.
Wow, that is so interesting.
Yeah, it's real. I'm not as up to the speed on this technology as some of our other guys are, but it thrills me to see the level of data that we can get and use from a both surveying and engineering perspective. A couple other projects that we've done that have been of value to our clients is we're working with the NRCS on mapping and providing flood zone and floodway mapping. And so what Brandon is talking about right here is a LiDAR scan that we had done for drainage, and our client wanted to be able to take cross sections through that so they can analyze the floodway. So Brandon's showing us in this how the technology can address the vegetation and then take quick cross sections for use by the engineers in a flood zone.
Line to look at your entire river valley. So I have it right now looking at every 100 feet. So again, we just flew this yesterday. This is data. I have it looking at a 5-foot swath. What that means is that in this river valley, so you can see the plane that's showing up here, but in this river valley, everything that I have highlighted here gets looked at for this cross section. So let's just look over here at this little vegetation spot. So we can tell that we get some vegetation here. And again, this is looking at
so you can't do this with regular photogrammetry. You've got to use the LiDAR. You got to use that penetrating laser to get to the ground. The only other way to get this level of detail would be to survey it conventionally, which still has its place. But on a big scale, this technology is much better.
We could make this more perpendicular. So just some options for looking at river valleys.
And Dave, we do already we are starting to have some questions come in, but we're going to go ahead, just for those of you that are tuning in, we'll just let you know we're going to go ahead and answer those questions at the end. Thank you so much for your participation. These are great questions so far from Tina Slater and John Dolinar. We will definitely be, Chase Corbridge will definitely be answering your questions at the end here. Thank you for typing them in, and feel free to type more.
Shout out to Ike. How are you doing, Ike? So I could go on. I could drone on about this for a long time here. No pun intended. I want to just share with you guys the video that I took on this project didn't turn out, but yesterday, Mark, one of our surveyors, and I went out to Lake Caddy, just here east or west of Laramie, and Mark's looking at a sonar, and we have a hell of a project, and we have to map the bottom of Lake Caddy, which is a fairly large reservoir. We've done mapping of, it's called bathymetric mapping. We've mapped several dozen lakes, but we've always done it with conventional technology. We would go in a boat with a GPS unit and measure the bottom of the lake. At every place we take a shot, and we would generate a map of the bottom of the lake, topographic map, using just regular grid points. Well, this lake's too big. I looked into a variety of technologies and found a technology that allows us to drive over the lake surface. It gathers the depth information, pairs it with the GPS information, and maps the bottom of the lake as we go. Mark, unfortunately, I have to be in the office today, so Mark is out freezing his butt off out at Lake Caddy. It's about, I would say 20 degrees. But what we're going to be able to do with this is help in the lawsuit between the Lake Caddy Irrigation District and some landowners related to the depth of the lake, and hopefully we can negotiate, help be a part of a negotiation between the landowners and the irrigation district on where they can potentially settle on the high water mark where the irrigation district can keep the water levels at. So this is going to get brought into court. I'll be on the witness stand defending this data as a professional surveyor, and without this level of remote sensing technology, we wouldn't be able to provide this exhibit to the court at a reasonable cost or at a reasonable time. This lake is 1.5 miles wide and 3 miles long. It would have been prohibitively expensive to do it any other way than this. So that's a project that is kind of fun. They may actually be fishing while they're doing this, but I told them that if they did catch a fish, that they had to call me so I could go out and help work. But anyway.
Well, goodness, Dave, it really sounds like the applications for remote sensing range from, they're just endless. It just seems like they range from, typical land planning to ownership disputes, disputes like you mentioned here on the boat in that lake, and even, measurements of a giant T-Rex outside the University of Wyoming. And even, one of the ones that was most fascinating to me was the kiln measurements that you all did and the savings, over, $5 million replacement savings for that company. That's really quite a breadth of applications for remote sensing, would you say?
Sure is. It sure is. And if I had, I'm really looking forward to seeing the deliverable that Brandon's going to bring back on this mine, because it's going to be so cool. We'll be able to see the wormhole of the underground mines as they traverse through the mountain. It's going to be. I'm glad I didn't have to go, because the mine height is only like 5'6" and I'm 6'10". I wasn't going to volunteer for that job.
Wow, that's really something. It would be really cool if we would be able to see that maybe next time, or at least a static image of what Brandon captured.
I'll make sure we put that out there.
Wonderful. And for those of you who don't know Brandon, who's the gentleman, one of our colleagues that's in the mine today, we've mentioned him a few times on this live chat, and he is actually one of our survey chiefs and also our UAV technician. So he does a lot of the drone flights for our company. Dave, do you have anything else other than those samples? Is that basically about the wrap for remote sensing today?
That's pretty much a wrap of what I can share about what we have done and what we are working on. We've done dozens of flights for survey projects, ALTA surveys. We've done aerial mapping for subdivisions, land development projects, drainages. There's a wide variety of things that we continue to work it on. We use this technology on that's fairly routine.
Sure.
But one thing about our company is we always seem to find really cool and unique projects to apply technology to. And it's one of the reasons why I enjoyed being a surveyor, young surveyor growing up, watching the technology change from just surveying with a transit and a chain or a tape to through the variety of upgrades and technologies to GPS, and now we're seeing the applications increase with drones and remote sensing. It's surveying is an exciting profession for sure.
Yes, it's really fascinating to me. It really seems like remote sensing is almost something that any of us today, even if we don't need a typical, we wouldn't think that we would typically reach out to an engineering and surveying firm, but it almost seems that any of us today could think of a project that we could potentially call you for and say, I really want to assess this thing. Can you help me do that?
Yeah.
And it sounds like those are the fun projects for you all, whether it's mines or...
Those are the really fun. The really fun projects are the projects where we can take the data, solve a problem, and not only apply our engineering professional skills, but apply our engineering skills to it as well.
And Dave, you mentioned just now about just, watching the technology evolve. And that's something that I think so many people can relate to, even when it just comes to, our iPhones or our cell phones here, or just any of the software that we operate on. It's one day Apple will push an update and suddenly we no longer know where to find our apps and things.
Speaking of our iPhones, there are apps that you can purchase that can produce 3D models just using your iPhone. It's crazy.
Well, that's really something. And about the speed of evolution of technology, I find myself having to adapt almost every month or every couple months to an update to the Apple iOS software, or just even when Facebook changes some things and how they organize their content. And I can't imagine in the world of remote sensing how much technology might be evolving, and how important it must then really be to have really educated and skilled professionals on our team here at Coffey that are really keeping up in their continuing education, and making sure that.
I agree, Marissa, and you bring up a good point there. Anybody can go buy a drone now. Anybody can go buy a GPS unit. Anybody can become somebody that provides remote sensing data. The difference between us and them is that we are also professional engineers and surveyors. The public needs to be aware of the level and the quality of the data that they're getting as they choose somebody that will provide that data to them. The whole point of us as professionals is that we are continuing to learn. We're continuing to improve our knowledge base, and through our licensure, we're bound to help protect the health and safety of the public. And without that licensure and that expertise, there really is no guarantee that the Acme drone company is going to be providing the level of data that's needed for an engineer or a surveyor to provide critical decisions.
Right. It's almost like when you look at, a pill box, like a supplement, that you're interested in taking, and it says, these statements have not been, reviewed by the Food and Drug Administration.
Right.
Yeah, it's almost like, knowing that you have Coffey, which is a slew of professional engineers and surveyors. It's almost like that's the regulation that a lot of these other drones, or you could just hire a drone pilot who could provide information to you or photography to you from their drone flight. But then is that data being interpreted properly?
Correct.
And is it something that you can really rely on? And one of our core points at Coffey is definitely reliability and dependability. And I think that where these other drone flights might not be as regulated, it's almost like we can rely on our professional engineers and surveyors to do right.
Let the buyer beware. If it seems to be too good to be true, it usually is.
And didn't we have a situation where we purchased some, where we were looking into some equipment, and we luckily had the skills to understand that it actually even though the price was approachable, it just was not the quality.
That's exactly right. We've been through our learning curve on this, particularly with the LiDAR technology. We've through trial and error, we've looked at a variety of different technology providers, and thankfully, our sophistication in dealing with the data was enough for us to say and return technology to the provider and educate them as to why we can't use this for the level of for the use that you say that was unintended for.
Wow.
If you don't understand the data, you can't properly interpret the results. So Brandon is actually quite good at that, and between Brandon and our other professionals, we were able to sift through the data to make sure we didn't use something that wasn't appropriate.
Absolutely. Well, wow, that's quite an example. And I know in the many other examples of life, when we go to buy something and we see a price and we think, oh, maybe I could do this myself. That sometimes that's
right.
Not always the best way. Well, I think we can open it up to a few questions, Dave. Does that sound good to you?
Yeah. I noticed my old buddy Ike Dolinar had a question about the accuracy you are seeing between your drone information and the actual ground shots throughout the corridor. they're matching up pretty well, Ike. It kind of depends on the a variety of factors. You know, the environmental factors when you're doing a drone flight have a big impact on that accuracy. The wind speeds, you know, the barometric pressure, you know, how low you're flying, how high you're flying. We try to compare it to my phone. We try to match up the level of accuracy that's required for the particular project with the level of accuracy that we need to get out of the technology. On that reroute, that corridor reroute for that transmission line, they needed to be quite accurate, and we did a lot of painstaking additional ground control and checking along the way to ensure that the deliverable was spot on. And Drew is right on some of the projects where it needs to be really tight. We have been able to get within a centimeter in a lot of areas. But
Wow.
Hopefully that answers your question.
Yeah, go ahead and type, John or Ike, go ahead and type if you have any follow-up questions to that.
Or give me a call when you get a chance, Ike. I'd love to talk to you.
Dave, we did have another question about the scan that was of the building, the point cloud, I believe. Can you help shed some light on what the different colors are? It looks like Chase Corbridge was writing in.
I think in that particular case, it's the intensity of the return that we got. So the light beams would go out, they would bounce off glass, they'd bounce off different materials, and the return is the intensity of that return, and that can be used to you know, analyze as an analysis in and of itself. For instance, in our mine survey, they're going to use that intensity data to help see if they can't find gold in the actual tunnels that we're mapping. And other applications are for that intensity data are identifying different kinds of vegetation. I've seen algorithms that help identify potential locations of noxious weeds. There's a tremendous amount of data that comes from this technology. I couldn't begin to explain all of it or all the applications, but that's where my limited knowledge ends.
It really seems like the interpretations of the data are just endless, and that's really cool to have a team that, you know, can think outside of the box and think, you know, with this intensity that comes back from this measurement, what all can that intensity help us measure? So not just, you know, one particular measurement, but what else can we apply this intensity to,
right,
to understand the area better?
Right. There's been, you know, we've had some connections with the firefighters and the federal government and their need of the use of drones to do both assessments of both an existing forest fire and the results or the aftermath, looking for hot spots, looking for areas where of severe vegetation damage, a lot of data that can be used by those people. You know, I've read studies of drones being used, LiDAR being used to, you know, count sage grouse. I'm not a sage grouse guy, but that sounds like a pretty good application.
Wow, that's really interesting. Again, just the limits just it seems like there are no limits to what you can do with remote sensing. It's just this really exciting technology that's, you know, just growing and growing, as with most technology today, just evolving and more
evolving. It seems to be evolving rapidly, that's for sure.
Well, it's very nice to be on the front line of that evolution. We do have one more question from Tina Slater. She's asking, can you discuss some comparisons of data collected from a surveyor to data collected from the drone? Do you have any pieces of information or comments on that, Dave?
Well, yeah, we've done that a lot, Tina, and part of the routine of what we have to go through to perfect or calibrate or ensure that the drone or the remote sensing data is applicable to our use is to compare that data set with ground-based or ground truth data. And in order for us to feel like we can rely on that data, we have to check it. So, and like I responded to Ike Dolinar, we have to understand what the accuracy requirements for a project are, so that we can mission plan the remote sensing mission accordingly, and make sure that the data that we're collecting will be, if at all possible, usable for you as a civil engineer to use. We need to make sure that you have reliable data so that you can do your job.
Absolutely, especially with emerging technologies, we have that responsibility to have those redundancies in place, as you say, with a lot of the ground checking that you are doing in a lot of these different projects. You're not just taking that drone and flying it over, you're also, checking accuracies, ensuring that they're within a centimeter. It's very, it feels, kind of consoling to know that that there are those redundancies in place as well with this new technology, and just seeing the accuracies is really something as well.
It's pretty exciting. It's pretty exciting. It's going to help. It's going to help. It's going to be another great tool in our toolbox to drive value for our clients.
And we got a thumbs up from Tina, so it looks like we went ahead and answered that question enough for her. Dave, I have two more questions for you. Do you know around when remote sensing became a part of Coffey's services? Or is it hard to kind of pin down because...
Oh gosh, like I said, remote sensing became a part of our services. The moment that I took the company over in 2004, we were doing some level of that technology already, but it has grown and grown and grown until about 3 years ago, when the UAV technology became affordable to the industry, and it has just skyrocketed from there.
So it really seems like the UAVs have just taken that skyrocket. You've hit that curve, and now really turning the page on the speed of progress with the UAV.
Exactly. Mm-hmm.
And so you've been doing some form of remote sensing for at least 15 years.
And even before that, while I was working for Enberg Miller Engineers, we didn't call it that. Understanding what we were doing is we were providing remote sensing data to our client.
And that's an interesting point that, it wasn't called that. So would you say remote sensing is the large term now that is widely recognized amongst engineering and surveying?
If you want to say that it's the most politically correct term, I think that's the case.
Okay, good to know. And I have one final question for you. What do you think is the most critical part of remote sensing? Would you say it has to do, we spoke about, how educated the team is and how important that is and providing reliable information? Or would you say it's the technology itself, the quality of the technology?
I would share the most critical piece of of an end user, the end user needs to be educated enough to understand the quality of the data that they need in order to accomplish the project, accomplish the goal for their project. They don't need, like for instance, if a real estate agent needs somebody to go and fly and get some cool aerial photos so that they can sell, some house somewhere, that is not necessarily a high accuracy endeavor for remote sensing. It's certainly worthy of the technology, but that's not something that Coffey Engineering and Surveying is our expertise is particularly suited for. However, if we're talking about gathering data on a bridge structure that's highly accurate and will be relied upon from structural engineers, that is not something that, in my opinion, Acme Drone Company should be providing data for. That data should be gathered and processed and checked through and with the direct supervision of a professional.
I see. So it sounds like the end user, the client, or whoever has the question, geez, I could really use some remote sensing on this particular area. It sounds like the best thing that they can do is get a little educated as to how accurate they need
Right.
the results to be. And that would be something that it sounds like Coffey definitely does and talks.
Yep, we talk the language and we can help a client understand the best and most cost-effective way for us to collect the data for their need.
Sure.
Sure.
And even, just a little bit further than that, it sounds like, I know when I was speaking with Brandon that he actually, with a couple other colleagues, trained some of the clients in gathering this information themselves, particular clients that are a little bit more involved in the industry. I believe it was the NRCS, so that they could, better capture this information themselves. Is that about a correct understanding?
I completely agree. Absolutely.
So that's something really great that I think, we offer to be able to, help provide that training a little bit and that analysis. Even in Brandon's videos that you displayed earlier, you can tell that they're, narrated in a way where he's explaining the data to whoever would be viewing the video. So that's certainly helpful.
I think so too. Yeah. We intend to do some more of that.
It looks like we have one more comment from Chase Corbridge. He says, agreed, end user dictates the need. If all you need is some marketing photos for Zillow, Acme can do it. If you want the accurate, reliable, reproducible data, you need to utilize a licensed professional.
Spoken like a surveyor, Chase. There you go, buddy.
Well, that about wraps our time here. It doesn't seem like we have any more questions. Dave, do you have anything else to add, or you think that was a good summary?
Well, that's a good first live Dave. I thought that was fun. It was interesting. I really appreciate the audience engagement. It was good to see my old buddy Ike Dolinar log on. Give a shout out to my cousin Crispin Anderson. Hope you learned something about what I do and what my dad did. Drew Burr. Drew is a good young engineer. I don't know why he's logging on to this. He should be taking the PE exam right now. So get back to work, Drew.
Well, Drew has been super helpful. It looks like he's been piping in. Thanks for being a great colleague, Drew. You've been piping in over the chat. As the two broadcasters that Dave and I are, we don't have the ability to type in the chat box, so we just speak to these comments. But it looks like along the way, Drew's been answering and deliberating with some of the other listeners. So thank you.
I appreciate Rob Ladig's shout out about my shirt. I was wondering if anybody would appreciate the colorful shirt. This is my style.
Yes, Rob said something like, wear the shirt that you want the weather to be, or something like that.
Exactly right.
Well, one final note for everyone. Again, of course, thank you so much for tuning in. We will be doing more of these. Each month, we're taking a topic and we'll be discussing it in a live session. Also, if you just follow us throughout the month on Facebook, LinkedIn, and Instagram, you'll see throughout the month all of our posts, and our blog posts and our articles will all be around a particular topic. So this month, the month of April, we were really honing in on remote sensing, and next month we have an exciting topic. We have subsurface utility engineering. So we look forward to talking with you all about that next month. And finally, because you have tuned in today, you have some information that was only displayed through this video, and so we are going to do a giveaway for those that have listened in today. If you just stay tuned to our social media posts over the next couple days, we will be asking a question on social media that has to do with a piece of information from this video today. And if you answer it correctly, the first person to do so will get some coffee gear. So please do stay tuned for that question, and hopefully you'll get some cool coffee gear sent to you in the mail.
Excellent.
All right, everyone. Well, thank you so much. And this video will be posted permanently on our page. So feel free to refer back to it at any time, or give us a call, or visit us at coffeyeng.com to contact us with any questions. That's coffeyeng.com. Thank you all so much for tuning in today.
Thanks, Marissa. Thanks, everybody.
Thanks, Dave. Bye.
Bye.